parallel lines. The main word in parallel lines that matters today for us, and it matters always, but you're going to distinguish between a couple things today. The main one here is these are coplanar lines, meaning they lie on the same plane, right? So coplanar lines that do not intersect. So parallel lines will look something like this, let's say. Okay, they're never going to touch each other. They will go on for eternity, right? They'll never intersect. So the way we show that, first of all, if you're naming that lines are parallel, the symbol they're going to use is just two lines that look parallel. But if we're showing it on the lines themselves, you just use little arrows. So we would put an arrow here and an arrow there to show that those two lines are parallel, okay? And it's a lot like angles. If there's another set of parallel lines that we're working with, we don't want to say that all four of those are parallel because they're not, right? My orange ones would eventually hit my green ones. So if you have to mark different ones parallel, then you would do like the double arrow and then the triple arrow and then the quadruple arrow, right? So just add arrows each time you add lines that are parallel. So if you look at this box here, anyone think they can tell me two parallel lines? Sebastian.
Line CD and line AB. Or
yeah. Yep. Okay. So how, we'll say line. We'll call them lines. So line CD, we would say is parallel to. Okay. So we put that parallel symbol in there. And then line AB. Okay. CD is parallel to AB. Do you see anything else that's parallel to CD? So we're talking this line right here. So we said AB is, what else? GH would be, yep. I'm just going to make this one big, long parallel. And then EF. Okay. Notice these two, the CD and EF, people are always like, but wait, they're not on the same plane. But is there a plane that you can put through those two? Yes. Okay. So as long as you can put a plane through them, they can be parallel. Okay. Questions on parallel lines? That one shouldn't be terribly new to you. You've seen parallel lines before in other classes. That one should be familiar. Okay. The one that is probably new to you, maybe not, I don't know, is skew lines. And skew lines, the difference with this is these are non-coplanar. So they cannot lie in the same plane. They're not parallel, but they won't intersect with each other anywhere. So for instance, if I gave you, let's say BD as my starting line, anyone think they can give me a skew line to that? Andrew?
AG.
Oh, you're fancy. Yes, AG would work. AG isn't even a line that's drawn in, but AG would be skew to that. I'm going to highlight with lines that are actually drawn in here. Callie?
Is AE also?
AE would be, yes. So this line right here, right, it's going vertical. BD is going horizontal. If I extend those forever and ever, they will never touch each other, but they're not in a plane. We can't put a plane through both of these lines, right? So that's the difference between skew and parallel. Coplanar versus non-coplanar, but they will never intersect. Okay, so with skew, if you're dealing with a box like this, there's always going to be 4 drawn in lines that are skew. Can you tell me anything else that's skew to BD? CG would be one. What else?
EC.
EC. I'm going to just do the ones that are drawn in. But yes, you're correct. And if you told me EC, I would give you that. It's just that line is not drawn in, so I don't want to start drawing more lines in when we already have a bunch of stuff going on. EF would be one, and GH. Yep. Those are the 4 that will never touch BD, but are also not in the same plane as BD. Okay? And there is no symbol that we use for skew, but we would say, for instance, BD and AE are skew, or BD and CG. Pick any 2 skew sets of lines. That's fine. Any questions on skew? Okay, then we're going to talk parallel, but with planes instead. So how do you name a plane? 3 or more, okay? So you can do 5, 6, 7. You can do as many points as you want in a plane to name it. You have to use at least 3. So if I wanted to name a pair of parallel planes right now, anyone think they could do that for me? Amaya, go ahead. Yes. Okay, so she's naming the left side here, plane A, C, G, E, and then the right side, B, D, H, F. And just remember, when you're naming them, it's best to go in an order. It doesn't matter if it's clockwise or counterclockwise, but we don't usually want to zigzag back and forth. So just follow a circular motion with whichever direction you're going. Okay, how many other pairs of parallel planes are in this picture? There's 4 more planes, right? 2 more pairs of parallel planes. So top and bottom are parallel, and then front and back are parallel. Okay, any questions on that? Okay, so here's what I'm gonna do. I am going to just make a copy real quick of this. You're welcome to do the same if you want, or you can just refer to it. Oh, I did it. That's lovely. I'm just gonna move it a little closer here. Ooh, that's not what we want. Oh, and now my fat fingers are too, shoot.
Oh my God, it's so small.
I know, I can't get it to stop shrinking. Okay, let's just do this. Try again. There we go. So they're just going to ask you a few questions about that same figure, but with specifics now, instead of you getting to pick which is which. So it says which lines, and this is lines plural, right? Don't just pick one. Everything, we want everything that is parallel to AC. Is that the one we did already? Oh, you guys picked the one I picked in the problem. Let's change it since we already did that one. Let's do everything that's parallel. Is that right? Did we do that one?
No, we did CD.
Oh, we did CD. Oh, great. Okay, yeah, let's do AC then. So everything parallel to AC, right? Here's AC. What would be parallel to that?
BD.
BD.
EG.
Where are they coming from? BD, FH, EG. Okay. Now EG and GE, that's the same line, right? You don't need to name it both ways. Keep that in mind. Pick one or the other. It's not wrong if what the notes, like if you're correcting your homework tomorrow and it says the opposite, you're still correct, okay? How about skew to GE? So here's GE, and we want to be skew to that. CD would be one. Okay. AB would be one. So never touching, but not in the same plane. 2 other ones that are drawn in anyway. DH. And BF. Okay. Yes, sir.
Skew can't be on the. Oh yeah, never mind. This is
Different plane.
a different plane. Yeah.
Yeah. Okay, then it says which planes are parallel. We already did the left and right, so let's just pick a different set. We're just going to pick one more set. Give me a different set of parallel planes here.
A B C D.
GE, so let's go GEFH so that we go in order. GEFH, and what would it be then?
A B C D.
ABDC, yeah, or ACDB, however, whatever order you want to go in, but just go clockwise or counterclockwise. Okay, any questions on those? Yeah, Amaya.
For the parallel planes, would you mark us off on the test if we didn't go clockwise or counterclockwise? If we did like zigzag?
I might take like a half a point off. Kind of depends how I'm feeling that day. Technically, it should be clockwise or counterclockwise. Sometimes I'm like, whatever. They're fine. Yeah. So try to go in order. Okay, so then it says what segments, okay, this is where wording really matters, right? Because a lot of times I give a problem like this on a test and students give me, instead of segments, they give me a plane because we're saying what's parallel to plane ABFE. Well, ABFE is that back plane, right? But I'm not asking which plane is parallel to that. I'm saying which segments are parallel to that. So what segments would be parallel to that back face? CG, CD, it's all the ones that are on the plane that are parallel to it, right? So it's the 4 segments, CD, DH, GH, and CG are all parallel, but we're gonna name them as segments. So CD, DH, HG, and CG. Okay. Any questions on that? Okay. Another term that you need to know, and this one is going to show up a ton in this chapter, and not the word, but the thing that it's talking about. It is going to be in nearly every problem you do. It's called a transversal, and that's just a line that intersects 2 or more coplanar lines at different points. So, for instance, I have a line here and a line here, right? A transversal is any line that cuts through both of those. Are you chilly? Oh, you're unsweatshirting. Are you hot? Yeah? Is it hot in here? Yeah. So a transversal will just cut through those other lines. So my transversal in this problem is this one. Right? That is a transversal. It's cutting through my other 2 lines that are there. Okay? Oftentimes, those other lines are parallel lines. Not necessarily so much today, but moving forward, most of what we do is going to be parallel lines that we're working with. So that will make life much simpler, and I'll show you when we get there. Okay. These are the types of angles we're going to talk about in this chapter. You need to know these like the back of your hand by the time this chapter is done, and you will. Like, we will talk about them so much that you're going to be like, yep, I got that. Like, I know what those are. But let me just explain to you today what they are. They all have an abbreviation that I use. You're welcome to use the abbreviation, or you're welcome to write the words out. It's a lot of writing if you write the words out. So alternate interior angles is AIA. Same side interior angles we call SSIA. Corresponding angles, I don't know why, but I just always end up writing this. I always just go core angles. If you want to call it CA, I'm okay with that, but I have done this for so many years calling it CORR that I just can't make my brain turn it to CA, but I don't care if you call it CA, okay? And then alternate exterior angles. So you are welcome to use those abbreviations. Don't use any other abbreviations because I don't want to have to try and decipher what you're actually talking about. But if you use my abbreviations, you're fine, okay? Okay, so remember, I think it was chapter 1. It was chapter 1. You had a picture where I showed you this is the interior of an angle and this is the exterior of an angle, right? I'm going to do the same with this line here, this set of lines here. The good news is I can always see when that happens because it like flashes so boldly. Okay, so I am going to highlight this. Ooh, oh, that's a very dark, oh, because that's the pen. Shoot. Undo. Sorry. This is what I meant to do. Okay, so this right here, everything that's between the 2 lines, we call those the interior angles. Okay, so that's this whole chunk. Everything outside of that, so shoot, here and here, Okay, we call that the exterior. Okay, so I want to see if you guys can use some of the deductive reasoning that we've been doing. God bless you. And figure out what these angles are. Okay, so there's a picture with 8 angles there. 1, 2, 3, 4, 5, 6, 7, 8. 8 different angles. Anyone think they can tell me 2 angles that are called alternate interior angles? Sebastian.
Angles 3, 6, and 4, 5, or 5, 4.
Okay, just 2 angles. Which 2 angles are alternate interiors?
3 and 6.
3 and 6, good. So these 2, 3 and 6, are alternate interior angles. When you see the word alternate, alternate, think opposite, okay? They're on opposite sides of the transversal. So opposite sides of the line that's cutting through, but inside the 2 parallel lines, or the other 2 lines that may or may not be parallel. So 3 and 6, and then the other one is 4 and 5. Okay. Okay, so those are alternate interior. Anyone else want to try same side interiors? Amaya.
I think 5 and 3.
On the same side of the transversal, so angle 5 and angle 3 would be same side interiors. They're on the same side, but they're inside the 2 lines, right? What's the other set?
4 and 6.
4 and 6. Sebastian.
When did we cover this before? In math 8 or 7 or algebra?
Did you do this?
No, I've seen this.
These names?
Yeah,
The types
I've
of
done it
angles?
before.
Really?
Yeah.
Does anyone know where you've done it? You've
I
not
don't-
seen it?
Last year.
You went to Valley, right?
I came to Valley in 8th grade. I think I did it 7th grade.
Oh, so you didn't do it at Valley.
No, but I remember seeing it. I think I did do it last year, huh?
Yeah, I think so.
In algebra?
The pre-algebra.
Not our algebra.
We did it in Miss Brandon's room.
No.
You guys
Maybe she was just showing you it with, it's not in the algebra curriculum,
Yeah.
but maybe she brought it in because she's also a geometry teacher. So, geometry teachers, we love to bring geometry into everything.
Yeah.
But yeah, it wasn't in the curriculum. I know that, but I'm glad you've seen it before. Okay. This one's probably the one that tricks people the most. They're called corresponding angles. Think about the word corresponding, okay? If something corresponds to something else, they are like each other, I guess you would say. Anyone want to take a guess at what 2 angles might be corresponding?
1 and 4.
No. What are 1 and 4? Those are vertical angles. Yep. Corresponding. Callie. What did you say?
1 and 3.
No. 1 and 3 are a linear pair. We've talked about those too. Oh, so many excited people. Evan.
1 and 8.
No, but that's a different type of angle too.
2 and 6.
Yes, 2 and 6. Okay, so here it is. If you look at, you have a vertex up here and you have a vertex down here, right? This angle 2 is the top right from that vertex. Angle 6 is also the top right from that vertex. So they need to be in corresponding locations, okay? That's what corresponding angles are. So angle 2 and angle 6 would be corresponding, okay? So there should be 4 sets in any setup like this. Do you see another pair of corresponding angles? Andrew.
Oh, that and then
I didn't even hear what that was because I was
say
seeing
2 and 5,
2,
but
not 2 and 5.
Yeah, there would be 1 and 5.
1 and 5. Give me another pair.
3 and 7.
3 and 7
4 and 8.
and 4 and 8. Okay, so they are in corresponding locations. I'd spend some time on that one. I feel like that's the one that gets forgotten. So make sure you know corresponding very well. Alternate exterior angles, Callie. That would be 1 and 8. Opposite sides of the transversal, and outside, right? So angle 1 and angle 8. And then what's the other one?
2 and 7.
2 and 7. Okay, alternate exterior. And people always say, why is there no same side exterior? There are. Our book doesn't cover them. I don't know why. But you could say 1 and 7 are same side exterior angles. That's fine. It is nowhere in our book that they talk about same side exteriors, so we left it out. But you can definitely use them. The same rules will apply. Once you learn what the rules are, you'll be able to apply the same stuff. So, questions on that? Okay, we're just about done. We're going to go through this whole list here. So, naming all of these different types of angles from this picture. Okay, here's what I want you to do. I want you to talk to a neighbor or two. Make sure everyone has someone to chat with. Be inclusive here. Be welcoming. Be encouraging. I want you guys to work through 1 through 10 together and figure out what those all are. Okay, 1 through 10. Let's chat about this. What did you get for well, first of all, 1 and 8, right? Here's 1, here's 8. Those are alternate exteriors. They filled that one in for you. What are 3 and 5? Same side interior angles. Okay, saye. Is that what we're going to call it? Saye. Number 3, angle 1 and angle 5. What are those? California. Corresponding angles. Okay, or California if you're going to do the CA abbreviation. 4 and 8. Also corresponding, right? This is, remember, corresponding, if you're looking at the vertex, it's the bottom right with the bottom right, or the top left with the top left, or the top right with the top right. So those are corresponding angles also. 2 and 6?
California.
Also corresponding angles. Look at that. 4 and 5. AIA. Alternate interior angles. Opposite sides of the transversal, but inside the 2 lines. 2 and 7? AIA. Alternate exterior angles, because they're on the outside there. 3 and 6? Alternate interior angles, right? Opposite sides, but inside are parallel lines there. 4 and 6. On the same side of the transversal, right? This one's our transversal. That did not write. This is our transversal. Okay, so they're on the same side of the transversal, inside the parallel lines. So same side interior. SSIA. 3 and 7? Corresponding angles. Okay. Then this next batch, it says this might have some other ones. So we're going to just draw in some of what you already learned in the last couple chapters to make sure that we're clear on all the different types of angles we've talked about. Okay. So for instance, 7 and 6, if you look here, right, those are vertical angles. Okay. Let me clean this up a little, and I'm just going to take a copy so we can zoom in at the bottom. Let's see. Oh, my thing is working very slowly today. Okay, so with this picture, what would you call 5 and 7? Okay, supplementary is an option, or a linear pair, okay? Remember, a linear pair is making a straight line. So this is a linear pair of angles, or if you call them supplementary, I will give you that too. Okay. How about 1 and 4? Those are vertical angles. Okay, 6 and 3. What? Oh, I thought you said playa. I was like, Del Mar? Where are you going? So 6 and 3, right? Alternate interior angles. Okay. And then 5 and 6. A linear pair. They form that straight line. That's a linear pair. Or again, you could say supplementary is fine. LP? No. We're just going to keep it to those 4 angles that we abbreviate. We got enough abbreviations going on here. And then 7 and 8. Linear pair or supplementary. Okay? Good? It's not bad, right? So the reason we don't do more with this today is it's just a lot of remembering what each type of angle is. Uh-oh, he's gonna get it. He's stopping.
No.
Did he stop?
No.
Oh.
Yes.
Yeah.
But they know, you can bring in stuff, like
Oh,
papers.
okay. Sebastian found one, you guys.
If I go get it.
No, I'm not done.